Today, we want to look at inverters. First of all, we have been saying inverter, 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 inverter. Inverter, 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 inverter. Now, come to think about it. What is an inverter? What is an inverter? Don't quote my own. Where's the other side? What is an inverter? Tell me the definition now. Electrical. Is it an electrical device? Is an inverter an electrical device, man? Is it an electrical device? Huh? Sam, now you don't carry my phone. See this guy carry my definition. There is this thing that you can use to set up here. A little time to look at what an inverter is all about. You spend a little time. This class, you are not wasting time much. It's going to be a very brief class. Now let's look at an inverter. An inverter is an electrical device. Is it electrical? Is it electronics? Is it an electrical device? Is it an electronic device? Is an inverter an electronic device? Hello? One at the door my hand. Is it an electronic device? Because it has electronic component also. There is MOSFET, there is capacitor, there is this. So I can define my own as inverter is an electrical electronic device, electrical and electronic device, or electrical or electronic device that converts direct current into alternating current. We need AC to supply power to most electrical appliances found in Nigeria. We need AC to supply power to most of the electrical appliances found in where? Nigeria. Now you beginning to ask, what is AC and what is DC? AC is more or less like voltage from our NEPA or gen. AC is like voltage from NEPA or what? Gen. AC is like voltage from NEPA or gen. DC is like voltage from battery or solar panel. Voltage from battery cannot be used in our normal home appliances in Nigeria. Most of our appliances cannot use unless it's DC. And majority of the appliances that you can find, like our fridge, our microwave, our fridge, our microwave, our blah blah blah, all of them are DC, AC appliances, and we cannot afford to use them directly. We cannot afford to put our panel plug on this thing and expect this to work. We cannot afford to put our battery plug on this and expect it to work. That is where you see people asking question, is it an AC or a DC? An AC because e needs an inverter, an AC because e can work directly with an inverter, a DC because e needs an inverter to work. Guess what? We have DC fan, we have DC fridge, we have DC, everything has DC iron. Those DC equipment are those equipment that when I plug them to panel direct, solar panel direct or battery direct, they will power. Now e begin to interest you on one of the varying points of DC. If I am talking about AC in Nigeria, I should just boldly say the voltage in Nigeria AC supply is what? AC voltage in Nigeria is what? 220 to 240 stamped. sometimes 190 work, sometimes NEPA bring 150 for us a work. Some of the appliances misbehave when it's working, but fine. The voltage range, the suitable voltage range for AC in Nigeria is between 220 to 240 for single phase. Now good. Now when you come to DC, that is when you have problem with voltage. When you come to DC, that is when you have problem with voltage. Look at the problem. I pick a DC. The first thing I should think about when I pick DC is which voltage? Which voltage? When you see a DC supply, first question you ask is which voltage? Don't make mistake of somebody just give you a DC supply, you carry it and plug to the appliances. You are going to have problem because my DC bulb uses like 12 volts, 3 volts, 6 volts. Now if I supply 24 volts to a DC bulb that is 3 volts, what will happen? E burn immediately. So that means while I am dealing on DC, I should be extremely careful and mindful of the voltage. Otherwise, I'll have issue. So DC voltage is very dangerous. See the danger. My voltage coming is 48 volts. Now, my fridge is 24 volts, and I supply 48 volts to this fridge. Automatically it will burn. It will not negotiate with you. No negotiation, it will burn. If an inverter is 12 volts, put it on silent mode. If an inverter is 12 volts and your battery, they gave you a lithium battery. Okay, you have done that. They gave you a lithium battery. The lithium battery they gave you is 48 volts. The inverter that they give you is 12 volts. You just carry the inverter without asking question or checking. The next thing you hear is no negotiation. Unless the inverter has a reverse polarity protection. Hello? Reverse polarity protection. There are some equipment that when you high voltage protection. When there is high voltage, the breaker will trip off. Why is this guy standing up? Why is he standing up? Huh? There is chair in sis, right? Bring chair for him from sis. He's running from the front. So now, maybe he's among one of those Boko Haram members. So now, in DC is polarity bias. DC is polar. Do you know that you are biased? You know you are biased. Eh? Are you biased? What is the meaning of bias? Bessie, what is the meaning of bias? Can you eat tuwo shinkafa? Eh? You cannot. Bessie, can you eat tuwo shinkafa? Why? Can you eat edikaiko? Very well. Who can eat edikaiko here? All of us. Who can eat erintam? Eh? Okay, how many of you can eat cockroach? Eh? How many of you can eat cockroach? Hmm? How many of you can eat cockroach? Hmm? I will be in China very soon. I'm planning that if I get there, the first thing I'll ask is cockroach. I'll test it. Let me see how it tastes. It not concern me. No. So now, why is it that when you see an Hausa man eating tuwo shinkafa, you remove your face and what is this? You are biased. You are biased. That is why NYC came to board like to integrate people, carry them from somewhere, come a particular place so that you eat juju in Agbo. How many of us, okay, do you know juju? You know they go restaurants for Agbo. Which soup do you know that Agbo have? You have not started. Are you eating in your house? Hunger never wire you. Which soup do you know that Agbo people prepare? I am thinking that next month, beginning of next month or so, we will cook one Agbo soup here. Now Frank go cook am. We go buy bush meat, arrange am. We go cook ujuju here. So that people that are from another place, they will know that we have a very special delicacy. Jessica, do you know juju? Have you eaten it? Can you prepare it? No. So now, you see other people doing something, you don't like it. I come to your house, you don't want me to sleep in your house because you felt that I am an aboki, that I'm smelling. You are biased. You are biased. You see people on the street, you are driving, you carry precious, you left Musa, you are biased. Now, DC is polarity bias. When I mean polarity means two things of different two things of different look. Man and a woman. Man and a woman. Man is positive polarity, woman is negative polarity. Biologically, man is positive. I don't know. Physically, some men are negative. I'm telling you the truth. There are some men that are even worse than women. I'm telling you the fact. Some women provide for man. I've been to a country where woman is in charge of. It's woman that bring money for food, not man. The man will just be inside. Yes. Huh? You want to go there? Pakistan. So now, look at it now. Polarity bias means I dare not carry positive to give negative. I dare not carry negative to give positive. Look at this inverter. Can somebody bring up this? This inverter has two places. Whenever I see an inverter, I start thinking two things, positive and negative, not life and neutral. Hello. In DC, we talk about positive and negative. In AC, we talk about what? Now, a positive usually is represented with red color, is represented with colors, while negative is usually represented with black. In a telecommunication setup, the positive is represented with blue and the negative is represented, okay, the negative is represented with blue and the positive is represented with black in a telecom setup. Blue, because in a telecom setup, the light, the one carrying the most power is negative. They uses a negative signal. An inverter uses a positive signal, but in a telecom setup where we have our power is negative. Now, this is the battery terminal. This cable is called battery cable or battery terminal. Terminal is the same thing as cable. Now, any day, anytime, this inverter, the first thing you look at is the rating of this inverter. This inverter is 24 volts, right? If I carry this inverter, I put it on 12 volts, the inverter might have issue because I'm supplying under voltage, and under voltage sometimes can damage some things inside. If I carry this inverter and put it on 24 volts, the inverter, in fact, the issue is not might, it will have issue immediately, unless there is a high voltage surge protector here that maybe e notice that this voltage is high, but most of them doesn't have this feature. Most doesn't have this feature. If I am supposed to put this cable, this one is what? Positive. This one is what? If I make mistake and I mistakenly take this one to positive and take this one to positive, automatically the inverter will have issue. But if there is a fuse, polarity, reverse 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 protector, like if they put it in such a way that when you reverse it, the fuse will trip, the fuse will break, this issue will not occur. As in immediately put the fuse inside the cord, there is fuse inside, it will cut. So that is why most time we check the fuse first. There is an inverter they brought recently, 3 kilowatt cycle. They said it's not working. And how many of you are, I think Bessie was aware. They brought it to HQ. Now HQ down right. It's not working. When I lose the inverter, I discovered that the fuse cut. What could have caused the fuse? What cut the fuse? Definitely when the person was, it's a new inverter that they just bought from us. I think it's SMS, Circle, SMS. Now when I lose the inverter, when I tested the inverter, it was not powering. When I lose it, I test the fuse, I discover that the fuse does not have continuity. I have to look for fuse. I change the fuse and it start working. For instance, it's a customer inverter that is have exceeded warranty. I don collect 60k o. Abi? Daniel, I don collect 60,000 o because of the small thing when I know. That is not business. That is brain. Technicality, handwork. Handwork can pay you more than any other thing. Imagine that I tell the customer, imagine that the customer need it critically, or maybe it's 10 kVA, very big one, because the size of the inverter determine what they will charge you. I don't know, fuse cut. I will carry the inverter back to office. Imagine that you are one of these people that repair. Most of the inverter that you take to repair is fuse. Just on that. That's why sometimes I want my guys check it. I don't have that time. If I had my time, I would have gone into repair. Serious. And I am also looking for a very serious person that I will send for repair. I will send the person personally for repair. Now the person will stay, learn the repair and come back. I tried it with Donga, I think that one fumble. I paid money in Lagos, 3 months for the guy to repair. But based on the fact that that guy is my friend, he couldn't take the business serious. We have 22 inverter, he did not solve one. The one he solved, they later brought it back. At the end of the day, he said he's coming, he want to see him family in Lagos. Till date, he never returned. Imagine an opportunity that somebody has missed. And look at the town. Do we have anywhere they are repairing inverter? And you think that when you go into repair, you don't make money. People doesn't think well. So, if you know that you have credibility, that you are trustworthy, then you come forward. I will send you to go and learn repair. I will send you, I will pay your for learning. I will rent a place for you. Maybe you spend like 6 months. You learn. Then you come back. We'll open a space here. Then we open a space. Me and you will sign memorandum agreement. A particular year that you work here before you can go out. Because I have tried now. So we can sign like 3 years. So you work with me 3 years. And at the period that you are working with me, we'll do maybe 60-40. So that at least you can still be making some things. So I dey give una business initiative now, you no go thank me o. So now that is polarity bias. DC is, I think Precious is already thinking of going to learn how to repair. Go hard o. You spend like 6 months, you never know one component inside inverter. 6 months, I swear. So but it's good to learn it. So anybody that knows that you have the capacity, just come and meet me. I will send you for the training. Honestly, I will sponsor you. I will pay everything. Then when you come back, by the time you start working, I collect my money back. Then you work with me for some time. While you are working, I will make sure that you still train one other person so that when you exit, we'll continue from there. So now, I think Daniel is already thinking that direction. Abi, you go gree leave your mama. Eh? Eh? You leave your mama for 6 months. Eh? You don't leave am. Okay, donkey. No, im mama end up na. No be that one na. So now that is an inverter for you. Now the quick one, looking at it, look at this. This is an inverter. E convert DC, this single of DC to AC. That means we have how many building block for an inverter? How many building block for an inverter? We have the input. The input is what? AC supply, DC supply. Then we have the output is what? Now, the next thing is originally an inverter was meant to convert AC to DC, and I bring in an external charger. In those days that we do this work, we put our inverter, come bring in an external charger. One day I wake up, these China people, they now put the inverter, the charger inside the inverter, because if I'm using this thing with my battery, I'm using it. At a time, the battery will run down. What will charge it? That is why we now put external charger. That type of external charger, we just put it beside, and the charger will be recharging the battery. Now, this people now think and bring in external charger into the inverter, so that while you are using, if there is light, light will charge it. The same people also think and say, okay, solar panel, they integrate charge controller inside, so that if you are using it, if there is sun, the same inverter will charge. You understand? So technology is evolving, and I think the next point of this technology now is where you have a single unit, very big, that you just plug your panels, finish. Everything will be inside. A lithium battery carrying an inverter, charge controller, and everything inside. So now, the system voltage is the input voltage on the DC side of the inverter. The system voltage is usually graded in step of 12. Hello? Is graded in what? Step of 12. 12 plus 12, 24 plus 12, 36 plus 12, 48 plus 12, 60 plus 12, 72 plus 12. Those are the inverters that we have. 12. You cannot see 6 volts inverter. Hello? Now, the common one here now is 12, 24, 48. In those days, we used to have 36, but it's no longer common. 12, 24, 48. Before, we used to have 198. We line up battery. We suffer this work. Oh. Some of us, I think some people, man, someone like Pascal met our relative suffering. Very, very bad beginning. See, we will carry like 12. How many? Is it 12? 12, I mean 11, 12, this thing, 12 times 12. We now install it, hang it. Oh, there is no rack, no battery rack sef. We connect it on the ground, connect, find this thing. Very bulky work. That was then. I will share some of our humble beginning to you. You will laugh tire. You even see me on the roof sef. You see me on the roof at the beginning of this thing. So now, you know, when you look at Sharon mouth, you be thinking that Sharon did not lick the mother's breast, abi? Because she has grown big and old. On the input side, the inverter is connected to the DC input power source, e.g. directly to the battery bank or solar array. The output side supplies AC power to the consumer, usually between 220 to what? 240. Don't forget o. 220 to what? 240. Now let's look at this. Classification of inverter. I have two basic way of classifying my inverter. One is I classify both on the input voltage. Then I also classify both based on output waveform. Now I have grid tied inverter. Grid tied inverter convert DC electricity from the solar panel to AC electricity, which can be usually conventional grid tied. Hello, grid tied inverter convert what? DC electricity from the solar panel. Give me example of grid tied inverter. Daniel, hybrid inverter. Clap for him. So don't get it twisted. When you hear grid tied, some people will think that it has something to do with NEPA. No. It converts straight from. Then also I have, okay, so grid tied inverter comes in various sizes in what? To match the power output from the solar array. Kilowatts. That is why you see 5 kilowatts, 10 kilowatts. Some people go say 5 kVA also, 10 kVA, and the rest of others. Now, hear this again. A grid tie inverter supply electricity to the end user and usually are unable to charge batteries. You understand? And they are not battery based. Hello, straight from the panel. There is chair inside my office. There is chair here. Destiny, come and sit down here. Straight from the panel. Straight from the panel, e convert. Grid tie inverter cannot function as standalone equipment without a connection to the grid, a battery inverter or a generator. Now let's look at battery inverter. A battery inverter convert DC electricity from the battery to AC electricity, which can be used by conventional. Battery inverter comes in kVA rating. Hello. Inverter with lower power output below 1 kVA usually use a low battery voltage. Now look at this. From 0.8 kVA to 1 kVA, we usually use 12 volts. From 1.5 kVA and above, we usually use what? 24 volts. But present, I think there is 12 volts. 2 kVA that is 12 volts. It's a modification to accommodate panel. Now, 2 kVA, 24 volts, 3 kVA, 48 volts, and so on. We also have 5 kVA that is 24 volts. Hello, 5 kVA, 24 volts, 3.5, 24 volts, 3.5, 48 volts, and so on. Just look at the voltage that you are working on. Then there is also another classification of an inverter. I told you that I classify it in two ways. When it comes to the output voltage, when it comes to the output voltage, when I come to the input voltage, that is when I talk about this frequency, high frequency. Hello, I have an inverter that uses high frequency hybrid. So that is when I talk of high frequency inverter, hybrid inverter, high frequency inverter, grid tied inverter, and the rest of others, because I'm looking at the voltage of the inverter. Then I can also classify an inverter according to the output waveform. Now, such classification goes in this direction. Such classification goes like this. There are 3 types of output waveform found in inverter. 3 types. I have the square wave, then I have the pure sine wave and the modified sine wave. You need to imagine where they write an inverter, pure sine wave. Now, look at this thing. This thing in carpet form. Are you seeing it? Don't look at all of them. Look at this carpet form. E come like this. E come like this. E come like this. That form is called square wave. It's in square. It's not fitted. It has a lot of. How many of you have on your better pass my neighbor generator? You'll be hearing the sound of the generator inside your fan. Inside your radio yourself. The generator will be sounding inside your music. Eh? How many of you? We no experience life. So now this one like this is called what? That is the method we use in answering our question. Sine wave. E move in what? Snake form. They call it sinusoidal. E go up. The other one is like almost like direct. The conversion is not complete. It's close to DC. So because it's not filtered, that is why it will not be in this form. You understand? So, but once you filter it, it will take a smooth form and move in sinusoidal form. Then another word is waveform. Wave. That is wave. Then also we have pure sine wave. Modified sine wave inverter are the midpoint between the square wave and pure sine wave. Most household and small office equipment will run on this inverter. That is the one we call sachet inverter. That is the one we call sachet inverter. Now, functional block of an inverter. DC will go on, DC will go in. It has a switch. By the time I supply DC, I have a switch. If I on this switch, this is the switch. Immediately, this is the switch. That is this button. Immediately I press this button, here we close. I don't know if you understand. Immediately I have 12 volts here. Because this button I have not pressed it, this one is open, there is no supply. The inverter will not on. Now immediately I press the button, this button I will push it. Once I push this thing will now close. Then once it close, the circuit will become complete. It now goes into the inverter. The inverter will work on it and bring out what? Output. This place is called switching circuit. What are you want to ask me? Let me finish now. Keep your question. Let me finish. I'll give you time. So now, if I have a DC in and I have a switch, once I close my switch, just like your normal fuse, it can still be, sometimes they will use this if you open this thing, what you see is just a switch like this. Look at this. Light off. Oh. Light off. Why? Why did the light off? Huh? I close it. Why did this light off? The circuit has turned to like this. Huh? Then when I press it, see now, see electrical people. See now. Precious. Look at it. The DC input supply say 12 volts is fed to a switch circuit, which makes and break the current path on a fixed regular interval. The switch on or off time is controlled by the switch control circuit. The output of the switching circuit now is rather quasi AC than DC. By the term quasi is to be understood that the AC is not the type of AC in which the flow of current reverse periodically. In the present case, the current either flow in one direction or do not flow at all. In technical terms, this AC is shifted in voltage axis by a level of equal to its negative swing. I think some of us will not understand this angle. You need to be technical to understand, but that is exactly what I've explained. Now, parameter of an inverter. The basic parameter of an inverter are as follow: rated power output. When we talk about inverter, the next thing we think about, what is the power output, rated power output. This parameter indicate the continuous power that an inverter can deliver in normal operating condition. The unit for rated power output is what? VA. When we put K, it becomes what? That K means what? Give me 1K. Pablo, I need 1K then. Who get 1,000? I go double am. If you give me 1,000 now, I'll give you 2,000. Let's do this now. If you give me 1,000 now, I'll give you 2,000. Don't get. Where's the 1,000 now? No, the one here. If you have 1,000 here now, bring it out. I'll give you 2,000. Let me see the rich people. God bless you. Akara don't do for me today. Ah, Ruth is a good girl. Oh. Ruth has just blessed me with 1,000. Now, look at this 1,000 this morning now. How much is this? We call it 1K, right? If I don't want to say 1,000, I'll say 1K. Not be what this land so. Now correct. That K means what? 2,000. Don't worry. Next time I'll double it. Now, the power is expressed in VA because the inverter can also be used to power load with reactance like motor. Then I also have what we call nominal output. Nominal output voltage. It is the magnitude of output voltage that the inverter produces steadily. This voltage is specified with fixed level of deviation like 200 volts for a given range of fluctuation of AC. So now this one produces 220 volts. That is the nominal output voltage that it produces, 220 volts. Now nominal frequency, it indicates the frequency of the output voltage or current waveform and expressed in hertz. As with the voltage, the value of frequency is also specified with tolerance level like 2. The frequency, inverter operates with frequency of what? What frequency does inverter operate on? 50 Hz. That is why when your generator is 45, it doesn't carry it. If you have a generator that is 45, you have issue. What is his name? You are distracting this na Chukwundo abi Chiwendo abi Chukwum. Wetin be him name? What is his name? Chukwum Chiwendo. You are being distracted. Frequency is what? Chiwendo. What is the frequency of an inverter? I told you that he's being distracted. Can you give him that phone? Can you give him my phone? My own. What is frequency? The person when they give us a problem. What is frequency of inverter? You know answer this one. You go back to level 500 level. What is frequency of an inverter? What value is the frequency of an inverter? Sit down. Because it's not with us, it starts depending frequency. Now let's look at efficiency. Efficiency of an inverter is an indication of the losses of energy occur during the conversion from DC to, whether I like it or not. If you are doing any conversion, if I am to convert Jessica to a man, so many things we lose, right? So many things. If I'm to pour water from my can to another can, there must be a loss. No? Let's practice it now. Bring a Regulus water. Let's pour it to the other can. There's no way that you pick 100% of that water into the other can. It will remain. You see some small water remaining in the other side. So the quantity that they gave you You cannot remove it and put inside the other one. President say it's a lie. We will practicalize it and see who will win now. You cannot. So efficiency, no machine can run on 100% efficient. It's not possible. No panel can produce 100% efficient. Lie. Now, efficiency of an inverter is an indication of the losses of energy occurred during the conversion from DC to AC. Efficiency is always in what? Ratio. What is the efficiency? What is the efficiency in this class? What is the efficiency in this class? In this class, what is the efficiency? What is your efficiency in this class? What this class? This class. Okay, what is reactant load? Okay, what is quiescent current? Igbo man. What is the relationship between? Let me leave you. Let me just leave you. The efficiency is expressed in percentage and is specified for the upper limit of load. Typically, efficiency of a good inverter exceeds 80%. Now let's look at maximum current. It is the current drawn by the inverter from the DC source in idle, no load. When there is no load, it's taking something. But Chinese has helped us that most inverter, when you don't put load sef, very low. But it's taking o. That is why if I plug this inverter on battery, after some time it will run down. Why? Because the inverter itself is taking, is drawing a little current. Before it's 5% o. The first set of inverter they did 10% sef. It will be running down by itself. Now let's look at surge capacity. Is the indication of capacity of inverter to deliver the power beyond its normal power for a very short period of time. Look at, I design an inverter that is 1 kVA. I add extra 1.2 so that when there is a mistake, the inverter can withstand the error. You understand? So that is surge. There are many. Now let's look at also types of inverter. Okay, I've done this now. I've done this. So now, output power rating. According to this rating, inverter are in low power up to 500 VA, medium power up to 5,000, and high power above 5,000. Those ones above 5,000 are high power. Now, this is an inverter for you. This is an inverter for you. Now, presently, we are talking about hybrid inverter, where we have high voltage, low voltage. And we say an inverter has, a hybrid inverter has a charge controller inside. A hybrid inverter has a charge controller inside. We have two types of hybrid inverter. The one that uses high voltage and the one that uses low voltage. The one that uses low voltage are transformer based. Hello, look at the voltage. There are ones hybrid that are very high. Those ones are no longer trending. They are no longer moving again. What everybody want to buy now is this Chinese what? Inverter. That is high frequency, high voltage. These guys has massively entered the market, thereby ruling off India. In those days, people that we know, if I bring this inverter and I give to a customer, they will say it's a China inverter. They will not buy. But believe me, almost everything that you are putting on here is from China. Check it. Abade, yeah. Even the material Abba is using from China. That one is Abamate. Where did they make it in Aba? Yeah, that button. The phone you are using, China. Biro. Your hair sef, China. Earring, Bessie big earring, China. The day that a small child, Sharon baby go draw that Bessie ear. Eh? This thing fit attract thunder. It's too much oh. If you attract thunder. I don't know what you see in big this thing. The day somebody will mistakenly pull am, the funny one is that he can even enter adult and he just draw it out of mistake. Let it not be that his root that will do it oh. So now I'm joking oh, whatever you want to wear you wear, even if your earring want to get to ground, no problem, as long as you are managing it you manage it. Now that is an inverter for you. Now look at the voltage. The high voltage inverter operate with a very high voltage. The concept of that inverter is that when the sun is going down, the voltage will still be normal powering. Imagine that I have a panel, the panel voltage is 32 and I connect all the panels in what? Series. And you know when sun go down, the voltage will go down. The voltage turn to 24 and the battery is 24. It will not charge the battery again. So but imagine that I'm having a voltage that is 360. No matter how it goes down, goes down, goes down, goes down, goes down, it will still be working gradually and small small until finally go up. That is the concept, and that concept has taken over the industry and is working perfectly. We have little issue in those days. Those guys that install the other type of inverter, they can bear weakness of some things. Now cable, you spend more when you want to use the transformer base. The transformer based inverter is more expensive than the hybrid inverter, honestly. 5 kVA transformer based inverter can be sell as much as 550,000. 5 kVA hybrid inverter transformer base can also be sell at even that rate. Then guess what? You don't need a charge controller. 60 amps MPPT charge controller 150. You have saved what? 150. Now when I'm using that transformer base inverter, I'm going to run a parallel connection. Because of my parallel connection, my cable should be very thick and big also. I will spend money on cable as well. Which one now is more favorable? Which one is more favorable? Yes. Now the reason why people dive off in those days is because these things are from China, and that time when you hear China, when you hear that they made this thing is made in China, you run that is fake. Is it actually fake? So the confidence, I think they've been able to restore the confidence back to the world that, let me not say they are the world power. So now I want to take question. What is time? We are shutting down. Question please. Oga, ask your question. Carry this over down. Go ahead with your explanation. Go ahead with this your explanation. Waveform guy, where will I see waveform now? Just explain what you're explaining. I'm listening. on one side of the printer. Then for converting it to DC, that means because on the side or that on the output of the cloud. When it starts moving to the other side, also need something. No, no, no. That means you don't understand. See, this concept here, this one here, look at this thing. Hmm? This switching you are talking, this one you are talking is the deep performance of inside here. Now, what we mean here, the circuit here is just for you to engage your what is it called? Inverter. Now look at this. What is this? Off and on. Now this thing has an affiliation with this place. For this guy to turn on, eh, this switch, I don't know if you understand. So now you are taking it deep into the electronic part of the switching from DC to AC. I cannot teach that one in a class like this because we are not in electronic class, we are an inverter class. If you want to go deeper, you get people so confused. Even this one is confused. So now, where you are going is beyond, is not a class for this, is an electronic class. You understand? I did power engineering, master's level sef. So not even this thing. So when you handle a class where you have mixed, this one is business. Which course? Health. Which course person? Hmm? Lab science, library science. Okay, this one I understand small. Some people sef na SSC science, secondary science. So you try as much as possible to make things easier so that they will not get confused. If not, you box somebody brain by the time you start explaining this thing. So now, this place I use it to represent the normal switch for them so that they can easily understand that by the time you turn on and turn off this circuit, that is when you have your DC, and without that DC engaged, this thing will not come up. So understand it in that form, please, so that you will not get the class confused. Any other person, please? Any other question? I want to ask my own. Oh, are you ready? Are you ready for my question? Huh?